This is the first part of a review session for Unit 3 in Applied Statistics. For this first part, we're going to talk about hypothesis testing problems. We're going to start with the first set of problems where the idea is to write the null hypothesis and the alternative hypothesis, then describe a type 1 error, and last of all, determine the appropriate type of test or the appropriate StatCrunch procedure to use. And we've got a list of what those different types of tests and different StatCrunch procedures are. For all of these, when you're thinking about writing the hypotheses, remember to look at the claim. That's going to tell you what kind of parameter you have, what your inequality is going to be, and what number to use in your hypotheses. You can also think at the same time about what procedure you would use in StatCrunch. Sometimes pulling up that procedure in StatCrunch will help you determine what your hypotheses are going to look like. Let's start with number 1. In this one, we have a survey, and we want to test the claim that union support for the Republican candidate is over 70%. So when we're looking at the claim, we're talking about testing something to do with the percentage. That means that we're actually testing a proportion. If we think about what we would do in StatCrunch, that means we've got a proportion test, and since we only have the one sample, that would be a proportion one sample test. As I was saying earlier, if you pull up that procedure in StatCrunch, if we pull up proportion stats, one sample with summary, that's going to give you an idea of what the hypothesis test should look like. We need to figure out what number to put in here and what inequality to put in here. The other thing about hypotheses is that we never use the significance level when we're talking about the hypotheses. You don't ever put the significance level into StatCrunch anywhere. For now, we know we're talking about a proportion, so our parameter is P. The claim is that that proportion is over 70%, so we're going to write our alternative hypothesis as P is greater than 0.70, and then our null hypothesis is the same thing with an equal sign replacing the inequality. So there are our two hypotheses. The type 1 error is always reaching a conclusion that you're going to reject the null hypothesis. In other words, that you're going to find sufficient evidence to support the claim when the claim really isn't true. In this case, it would be concluding that the union support really is over 70% when it actually is not. And again, in StatCrunch, what we would use would be the proportion stats one sample. Let's go on to number 2. In this one, if we look at the claim is that the average cholesterol content in a chicken egg is different than 213 milligrams. Right here we have the word average. That's a keyword to look for. In the claim, that means that we're doing a test about a mean. Our alternative hypothesis is going to be that the mean is different than 213. Different means using a not equal to. That means our null hypothesis is going to be that the mean is equal to 213. A type 1 error would be concluding that the cholesterol content is different than 213 milligrams, since that was our claim, when it actually is not, so when it's actually equal to 213 milligrams. In StatCrunch, anything to do with a mean or means, that means you're going to use t-stats. If we look at the t-stats, this would be a one sample with summary. Notice how it fits the information that we have. So it's asking for a sample mean, sample standard deviation, and a sample size, which we were given all those things in the problem. And here's what our hypothesis tests are supposed to look like. If we were doing this in StatCrunch, we would make that a 213, and we would leave this as a not equal to. Let's look at number 3. In this one, subjects were asked to measure their pain on a pain scale both before and after hypnosis. What that means is that for each subject there are 2 different measurements, and that tells us that this would be paired samples. The only procedure that we do that has to do with paired samples is about the mean of the differences. If we look at that in StatCrunch, we would be doing t-stats paired. This was the only paired one that we ever used in this class. And from this, if you pull this up, you can see what the hypotheses are supposed to look like. They have the mu with the subset of D for difference. In all the ones in this class where we had two samples or where we had paired samples, we leave the number in the hypotheses as a 0. So the only thing we would have to change would be the inequality. And for this one, since they talked about the before first, I'm assuming that we're taking the before rating minus the after rating. That means if the pain measurements were lower after hypnosis, that means the after ratings were lower, which should mean that our difference was positive. If we're taking a bigger number minus a smaller number, we should get a positive number. That's how I came up with the greater than to put in the inequality. This one, you kind of have to think through that to get that inequality right. For this one, a type 1 error would be concluding that the pain measurements really were lower after hypnosis when they actually were not. And as we saw in StatCrunch, this would be a T-paired test. Let's look at number 5. In this one, we're talking about the brain volumes of afflicted and healthy patients. The claim is that the average brain volume for afflicted patients is different than the average brain volume for healthy patients. First of all, we're talking about averages. That means that we're doing some kind of test to do with means, which also says that we'll be using T-stats in StatCrunch. And this time it's talking about two different averages, the average for the afflicted patients and the average for the healthy patients. So we're talking about two different means. That means that we're doing a T-stat 2-sample test. And if we pull that up in StatCrunch, we can see what the hypotheses look like. We've got the mu1 minus mu2 is equal to 0 for our null hypothesis. And then for the alternative, we just have to decide what that inequality is. This time it just says that the average is different. Different means not equal to. There are our hypotheses. Then for the type 1 error, that would be that concluding that the claim is true, so concluding that the average brain volumes are different when they actually are not. In number 6, the claim is that there's more support now for abolishing the penny than there was in 2004, and in 2004, only 23% of American adults supported it. That's saying that the percentage now that support it is more than 23%. Our alternative hypothesis would be P, because we're talking about a percentage or a proportion. It's greater than 0.23. So our null hypothesis would be that P is equal to 0.23. A type 1 error would be concluding that that claim is true when it actually is not. And this, since we're talking about a P here, this would be a proportion 1-sample test. Notice that they only gave us data from 1 sample, so we can't do 2 samples, we can only do 1. In number 7, this one we're talking about candidates who won elections and then the people that came in second place to those candidates. We're testing the claim that on the average, the winning candidates are taller than their second place counterparts. In other words, for each winning candidate, we're also looking at the person that came in second place in that race. So this is a paired sample situation. That means that our parameter is the mu sub d, it's the mean of the differences. And if the winning candidates are taller, that means that if we subtracted their heights, we'd get a positive number. So we want the mean of the differences to be greater than 0 for our alternative hypothesis. A type 1 error would be concluding that the claim is true, so that the winning candidates are taller than their second place counterparts when they actually are not. And this would be a T-paired test since we're talking about the average. That means it's T-stats, and since we're talking about paired samples, it would be T-paired in StatCrunch. For number 8, this time we have 2 different samples. We've got 40 claims from the 20 to 24-year-old drivers, and we've got another 40 claims from the 30 to 59-year-old drivers. We want to test the claim that the average amount for the 20 to 24-year-olds is higher than for the 30 to 50-year-olds. So this time we're talking about two different averages. We've got the average for the younger people and the average for the older people. So we have two different means. Our hypotheses look like this with the mu sub 1 and the mu sub 2, the two different means. And since we're talking about the 20 to 24-year-olds first, we're saying their claims are higher, then this would be a greater than for our inequality. A type 1 error would be concluding that the average for the 20 to 24-year-olds is higher than it is for the 30 to 50-year-olds when it actually isn't. This time, since we've got the two different means and we're talking about the averages for the two different groups, they're not paired in any way. That means it's a T2 sample test. In StatCrunch, we would use the T-stats 2 sample. In number 9, in this one also we have two groups of infants, one that used bed nets and another group that didn't use bed nets. They're not paired in any way. So we have two independent samples. But this time when we're talking about the incidence of malaria, that means the proportion of the infants that actually came down with malaria. So this is a two-sample proportion test. Our hypotheses have the P1 and the P2 for the two different proportions. And the claim is that the incidence of malaria is lower for the infants using the bed nets. Since the ones using the bed nets are mentioned first in the problem, that means that we want to make this a less than. So we want to make it fit what it said here, that it's lower for those infants. A type 1 error would be concluding that the incidence of malaria is lower for the infants using bed nets when it actually isn't. And this, in StatCrunch, this would be a place where you would use proportion stats 2 sample. In number 10, the first thing we can see is that the claim is talking about means. So the mean amount grossed by PG or PG-13 movies is higher than it is for movies with R ratings. We're talking about two different means, one for the PG or PG-13 movies, another mean for the R-rated movies. Our hypotheses are going to have the two different means in them, mu sub 1 and mu sub 2. And since the claim is that it's higher for the PG or PG-13, that means we're going to make this a greater than. A type 1 error would be concluding that the claim is true when it really isn't. And since we've got two different samples, we're talking about two different means here. That means in StatCrunch we would use T-stats 2 sample. One more of these. In this one we actually have the data. We've got prices for specific items at one particular store and at their competitor's store. The claim is that the store's prices are lower on the average than their competitors for specific items. Notice for each one of these items we have two different measurements, two different prices. That means that these are paired samples. For our hypotheses, we have the mean of the differences, so the mu sub d. Since the claim is that the store's prices are lower, then we want to make this a less than. A type 1 error would be concluding that the store's prices are lower on the average when they actually are not. Since we had paired data, then this would be T-stats paired in StatCrunch.